Thank you, Elizabeth. And thank you, everybody, for sticking through. It's a treat to provide some opening comments towards the last panel of the day, which includes a number of experts in the fields of computer science, data analytics, and artificial intelligence. And just to set the expectations of the handful of you here, I am not smart enough to be a data scientist. The last time I checked, my knowledge on this topic wasn't artificial and ties to experience that we have at our organization of helping 265 utilities. And we'll talk a little bit more about who we are and what we do. But really, my goal is to take some comments that I've extrapolated from the various panels throughout the last few days and do my best to try to consolidate some of that into a theme that's been pervasive since Andreas kicked the conference off on Tuesday. And that really all ties to the importance of data and what that means for the utility industry and how the access and analysis of data is really the basis of driving a lot of the transformation that so many folks have been talking about since we all convened here in Austin a few days ago. So with that in mind, just a little bit about Tantalus for those of you who may not be familiar with who we are. We've actually been around for a little over 3 decades. We are publicly traded up on the Toronto Stock Exchange. And our history and heritage ties to building out very comprehensive networks, predominantly for public power and electric cooperative utilities. With that said, we also support some of the largest investor-owned utilities in the country today, and our user community consists of 265 utilities, almost all of which are in the United States, some in Canada, and a handful in the Caribbean Basin. And at the highest level of what we're doing is helping those 265 utilities digitally transform their distribution grids. And we do that by deploying what we refer to internally as connected devices. Those are devices that have a Linux-based computing platform embedded on a module, coupled with both RAM and flash memory, and a custom ASIC chip which has 5 processors to parallel process data at each individual device. And so for us, a device can be a meter. We don't build meters, we partner with meter companies. It could be a load control switch, it could be distribution automation equipment, it could be devices inside the substation. And as we continue to expand, and we'll talk a little bit about this, you know, the heritage of AMI and people who are very familiar with that really goes down to the meter. Our focus today, with an increasing number of utilities we support, is beyond the meter and into the home, all the way to the EV charger, to the solar inverter, to the power wall, whatever else is deployed at the home or the building, with the goal of accessing, transporting, and analyzing that data from the very edge of the grid, the end, up through SCADA in a secure and reliable manner. And that's the view that we take, and that's the view that we are partnering with 265 utilities to try to help them resolve a number of issues. So with that in mind, I'm a historian, and so we still have a lot of people in the room. We'll try to get some audience participation, and the good news is Andreas just told me that he's going to buy everybody a drink who answers any of the questions I'm about to ask successfully. So thank you for your participation. It's a little awkward to be behind a lectern here as opposed to just sort of walking around, but does anybody know what was invented in 1880 that was important to the electric industry that we all are a part of today? And if that's too hard because 1880 is too big a thing, does anyone know what Thomas Edison may have done in particular in 1880? The light bulb. So Andreas just bought himself a drink. Well done. And that light bulb led to the first distribution system. Does anyone know where the distribution system was originally deployed? Manhattan, and where I come from, who knew? New Jersey. So we got partial answers, but I think we got a couple cocktails as well, Andreas. Make sure that ice is cold. Does anybody know when the first electric vehicle was actually invented? And it was not Elon Musk, just for the record. 1908 is close, but it was actually 1890. But we'll give you credit for participating. It was a 6-passenger vehicle that went at a lightning quick speed. I use that word specifically. We'll come back to lightning in a moment. 14 miles an hour. Right? But that was the start of the EV revolution. It's just taken us about 125 years to figure out what that actually means. And so we can go through this quickly here. All right, we had Tesla coming up with the AC system, hydroelectric, dating back to 1895. Does anyone know when the first utility was actually founded? If not time, does anyone know the name of the first utility? Commonwealth Edison, thank you very much. All right, so we've had a rich history here of now almost 125 years of utilities. And from there, first renewable. I kind of just gave the answer away. I clicked too quickly here, right? But the concept of renewable power actually dates back to 1911 in Italy. Who knew that the Italians knew how to make something more than pasta and very fast cars? Right? They started geothermal, which really is a source of renewable power. And so while all of this is happening, we started to see regulators surface. There were some pointed comments about regulators yesterday and the day before, so I won't go there. The Hoover Dam, which unfortunately is under duress right now with the water levels in the Colorado River, and a serious issue with respect to the impact extreme weather is going to have on utilities. All right, all the way to, does anyone know where the first solar cell was developed? Well, it's my home state, New Jersey, Bell Labs actually. They pirated technology from a scientist in Poland, but we'll give Bell Labs credit for it. Does anyone know where the first, so were you guys in the room when Andrea started talking about how we could canvas one portion of one state in the country to power everything with solar? So does anyone know where the first rooftop solar panel installation was? Delaware, that's good. So someone was paying attention to you, Andreas. So University of Delaware, who knew, pioneers in the concept of rooftop solar. And all of this happened before the DOE was created in 1977. Amazing that somehow industry figured out what to do without the Department of Energy or government officials. But if you think about that, almost 100 years from the light bulb to rooftop solar. So now I'm going to go a little faster, just in the interest of time, but we can still play here. Second slide, participation would be appreciated. Drinks next door as soon as this is all over, right? 1980. Anybody think of something big that happened in the 80s other than rock and roll and good times? Yeah, personal computing. Thank you, Andreas. All right, who knew an agriculture company named Apple could transform the way in which we do things with large organizations like IBM? And from the 1980s, thankfully Al Gore showed up and delivered the World Wide Web, which we just got an education earlier this morning that that's antiquated, and now we're on Web 3, which I had to go research because that was just a new term to me, but now I get it and what that means, and the evolution of networking in general, and the combination of PCs and web computing, networking, right, gave us an invention, right, that we all have in our pockets. Don't leave home without it. The iPhone. Anyone know when that was actually first delivered? 2007. You're going to be drunk. So 2007 is when we ultimately had the iPhone. And now when you think about it, my iPhone unfortunately got dropped into the water in the Long Island Sound last weekend, and it was like a panic attack. Right? I'm coming to Austin. It's like, how am I actually going to get through an airport without my iPhone? Because I don't print boarding passes anymore. And so, right, think about it. It changed the way in which we think as individuals, as the way we operate. Right? Some of you on your iPhones already not interested in listening or taking notes. I'll give you that. Right? But already distracted because in the palms of our hand, we can look up any worthless information, including the questions I'm asking right now about times and dates of when things happen. And so Tesla shows up with the Roadster in 2008. Very cool. I like cars, right? But in my mind, that was only going to be for the really affluent people that wanted to try to drive 54 miles an hour and a 55-mile-an-hour speed limit really quickly, right? But ultimately, think about the evolution of how quickly we've gone from the Roadster where we are today and the impact that we're talking about with EVs. So the Roadster came before the largest solar installation in the United States in Nevada. and the power wall not far behind it. And yet we still don't really have great answers at the utility level on how to deal with these types of technologies. So from 2015, right, the government's gotten involved, partly tied to try to help the economy rebound with stimulus dollars. But we're talking almost $500 billion being allocated to really predominantly help fix the grid, prepare for the revolution that's happening in transportation, and also deal with something that's surfaced that's a real socioeconomic issue, the broadband divide. And that rings true to us for a lot of the electric cooperatives and public power utilities that we support, where many communities, 20% in fact across the United States, don't have access to broadband power inside their home. And so while all of these good things are happening, right, in 40 years we've gone from the concept of personal computing to now a computer and a generator on wheels with the F-150. And so I'll come back to the word lightning. Right? It took 100 years to go from the light bulb to a solar panel. It's taken 40 years to take computing and putting it on wheels with a 19 kW battery, right? A generator for most people's homes in the United States, right? On wheels. And just as a complete aside, I don't work for Ford. I do have an F-150, right? I'm up here talking about trying to be more efficient, but yet I drive a gas-guzzling vehicle for my family. I do have a reservation in for the Lightning, and I did get a chance. I've shared with a few people. I got invited by our dealership locally, at the Ford dealership where I live, to test drive one. Has anyone test drove this F-150 Lightning? Does anyone have one yet? Does anyone have an electric vehicle in the room? Here, we got a couple. So the F-150 Lightning is frightening for a lot of reasons. One, in terms of the impact it's going to have on the utilities that we support. But two, you're talking about a truck that weighs significantly more than the existing F-150 weight. The battery is low. Andreas can just give you a visual of center of gravity, right? You step on that accelerator, it's not really an accelerator, it's a pedal, and the torque on that vehicle takes off. This is a tank. This isn't just running into things, this is driving through things. And it's on rails. So it's a lot of fun to drive. But when we think about 19 kilowatts in a vehicle, regardless of whether you think or how long it's going to take for that F-150 to discharge to power the home in that Super Bowl commercial, right? It's like adding 6 central air conditioning units on the side of a home for utilities. And while one F-150 Lightning, I hear this from utilities all the time, not going to be a problem, we can handle it. Well, guess what? There are 4 F-150s on my block where I live. I'm one of 4. All 4 of us are buying the Lightning at some point. Maybe not today, but over the next several years. That's going to impact the pole-top transformer on our block, which dates back to 1988, by the way. I know, because I've talked to the utility lineman there. He loves it when stuff happens on our street, because I like to go out and talk to him. The supply chain constraints for that pole-top transformer are about a year today. It's a serious issue at the distribution grid level. And so 100 years to go from the light bulb to the solar panel, about 40 years to go from computer to generator on wheels. And 13 years from now, if you live in California, you will not be able to buy a gasoline vehicle. And so thinking about how we help the utility industry, not just talk about it any longer. And there was a great question, I think Sasha asked it if I recall, right, to CPS. Are you prepared for V2G? And the question is, what does that mean? That's a real problem. I'm not being critical of CPS in any capacity, right? But that's a serious issue that utilities have to address. And so, what do we see with the grid today across the 265 utilities that we support today? There are really 3 key issues. I'm going to flip through this quickly. The first is extreme weather. Even here in Texas, we've seen from extreme freeze to extreme heat, one of which bringing ERCOT to its knees, a second of which in July being within 22 megawatts of bringing ERCOT to its knees again. Right? We have drought, we have wildfire, we have hurricanes, we have floods. Right? The grid, the resiliency of the grid today is at serious risk, especially at the distribution grid, where our pole-top transformers, our feeders, our circuits, the lines, and the distribution transformers are all old, and in many circumstances, still being run to a point of failure. The extreme weather, right, has become a political bargaining chip. Right? Calls to decarbonize everything. And the gentleman from Intel showed a statistic that about 75% of the greenhouse gas emissions are tied to the energy industry. Not necessarily just the utility industry, but the energy industry. So when you combine calls to decarbonize, and Llewellyn King referenced this, right, coupled with the pressure on utilities to support the electrification of everything, increasing power supply while changing the way that we do that and having to rely on sources of generation that may not be as reliable as we historically are used to, it creates serious issues, particularly in the distribution grid. And while the sexy stuff is at the generation and the transmission side, for good reason, it's the distribution grids where we all live. And it's the distribution grids that, in our opinion, is where the most investment has to happen and where utilities have to be the most progressive in adopting technology. So some of the challenges that we see utilities confronted with in trying to figure out how to address environmental impact, calls to decarbonize, supporting the electrification of everything, especially transportation, it's really in 5 key areas. From a financial perspective, utilities not only have to reduce costs, they also have to extend the life of existing assets, because in today's world with supply chain constraints, they can't replace stuff fast enough when it fails. From an operational perspective, not only do we have an aging infrastructure, we've got an aging workforce. And as that workforce is, right, aging out, how do we attract the younger generation to want to go work at the utility? How do we make sure that they're safe? Right? So workforce safety always paramount at every utility conference and every utility I go visit with. Beyond that, as 4 F-150s show up on my block, how does the local utility adjust their system plan to accommodate it? From a communal perspective, Llewellyn summed it up really well this morning. The utility is the lifeblood of community. It is the source of economic development. Without electricity, none of us are here today in this room thinking about how to solve problems that exist. It's a path for economic development. And not only does utility have to worry about just helping communities stay afloat from an environmental perspective, right? They've got to decarbonize, but there's an S component to ESG, which is how do they deliver the same level of service, not only to the folks that always pay their bills, but also figuring out how to deliver that same service to the higher credit risk members of their community, or the members of the community that just can't afford to pay. That's a serious problem, especially when we just look at that history of adoption. The first folks to adopt the light bulb were affluent. The first folks to buy PCs, affluent. The first folks to have computers in our hands through iPhones, right? People that are earning more money. The same thing's going to happen with EVs, with solar panels, and power walls. And so how do the utilities prepare for ultimately the lower credit risk members of their community islanding away from the grid and consuming potentially less power? And we heard that about fixed versus variable and rate structure. Right? These are serious challenges. So from a solution perspective, what we're doing to help utilities, and I'm going to tie this all back to artificial intelligence, I promise, Don and panel. Right? What we're working to do is modernize and digitize the grid. And so some common language. Right? We heard about the importance of common language. So we know where the grid is vulnerable and at risk. I'd reference connected devices. Having distributed computing is critical. How do we get computing as close to the point of consumption and as close to the point of where the action is actually happening? If you're a Six Sigma person, there's a phrase in the Japanese language of Gemba, right? Go to Gemba when you're trying to solve a problem. Go to the source of the problem. That's where we're consuming and where we're living and working. And so once we can get edge computing, whether it's a meter, a load control switch, or now a car, or a solar inverter, or frankly, distribution automation equipment, the next question is how do we ultimately get connectivity to it? And we've learned a lot over the last several days about the emergence of broadband, right? The emergence and transition from RF to cellular. Now, we've got some utilities that are dropping fiber all the way to homes. The city of Chattanooga in Tennessee is the shining light, the first 25 gigawatt city in the country. Right? At the end of that fiber network is a device from Tantalus that not only provides backhaul for everything that's happening, consumption and power quality at the edge of their network, but also delivering broadband in an economical and efficient way for people who can't afford to buy it from the larger companies like Comcast and Cablevision. And so the networking piece is really important with some great evolution. But once we get devices and computers in the field, and we can get connectivity to them, cellular, fiber, whatever the IP capability is, it then becomes all about the data. And for us, data is not just about billing. Data, arguably, important to know how much to bill, important to know how consumption patterns are changing with new technologies being deployed at the home. But the data that we're so focused on with our utilities is voltage, it's current, it's blinks. And with a new product that we're bringing into the market in the next several months with alpha test starting in a few weeks, it's flickers, it's power factor, it's harmonics, it's the analysis to do waveform analysis at every home. Not just a handful of power quality meters are being deployed at a few substations on a few key circuits. It's all of that data. From that data, we can drive seamlessly data into an increasing number of enterprise software applications, some of which are ours, some of which are third-party vendors, right? Harmonizing that data to make it accessible to any system a utility is deploying, and from there, analytics. And we've got a panel of experts that'll talk about some of those analytics. I challenge a bunch of you to also think about what's happening behind the meter and how quickly things are changing and how the concept of AMI is no longer adequate. This isn't just about meter data, it's about what's happening behind that meter. When you really think about the continuity and the security and reliability of the grid, right? Rooftop solar, EVs, power walls, smart appliances. How does the utility have access and not have to rely on homeowners' Wi-Fi, which really hasn't worked so well for the last decade? Right? I know at my house, I've got a 12-year-old son. Somehow, miraculously, he loses his devices or he wipes out the passwords. Well, he's smart enough now to change the password on the Wi-Fi at our house. For us, it's always a joke. I come home from a trip like this, none of my devices connect to the Wi-Fi. Why is that? Well, he's out playing with his friends. Then I realize when he comes home, he's changed the password. And it's some ridiculous password that you would never figure out because it's in the mind of a 12-year-old. That's a problem if you're a utility trying to rely on customers' Wi-Fi where you've paid them a $50 Starbucks card to sign up to do something crazy, like turn off their air conditioning, right? But when that Wi-Fi password changes, the device is dead. There's no return on investment. So what we're working on and what we've designed with a number of electric cooperative utilities in particular, and a handful of public power utilities, if I can get this to work, is a gateway. This is a device, and I won't go into too much detail about it just in the interest of time. But if you're interested in learning about it, I'd love to talk to you about it in more detail. But this is a device that will allow utilities that have fiber access today or are deploying fiber to connect directly to a meter, whether it's on our AMI network or not, doesn't matter. We've got an Ethernet version of this, if there's other forms of broadband, and we have a cellular version of this, 5G or private LTE. We've got opinions, but the goal is to let the utility select what they think is best for them. And on the back side of this, it plugs right into any standard meter socket, supports any type of meter. On the back end of this device is a Wi-Fi chip, a utility-grade Wi-Fi chip to provide that connectivity into the home, not for social media for my son or my daughter's TikTok affections and obsession, I should say, but we'll talk about my parenting skills another time. But but it's ultimately to connect to the EV charger, to the solar inverter, to the power wall, as we all at some point in time invest in those technologies. Or as utilities bring those technologies to us. And so the goal is not only access and data from the meter, but all of the data behind that meter. And so when we think about what that looks like for a utility, we got a great case study. Sorry, I'm struggling with the clicker here. Little lone city in Colorado. Has anyone heard of Telluride? Yep. Ski resort? Yeah, anyone skied there? Yep. All right. There's another little ski resort right there called Purgatory. Anyone heard of that? Yep. Well, when you go up to the top of Purgatory on their high-speed quad, they got a meter up there. Fortunately, it's one of ours. Not our meter, but our intelligence. And the town of Estes Park, small little 11,000 community supporting the city of Durango. But they also have the responsibility of running a circuit through Mountain Valley and the Rockies. It's not accessible by road, that delivers power to some of the most expensive real estate supporting Telluride, where a lot of people, it's a second, third, and fourth home. And so what we've been able to do is triangulate data through analytics. We capture blinks, we capture flickers, we're capturing voltage, we're capturing current. And what we've been able to help them do from a system planning perspective is think about how do they ultimately allocate their capital budget. This is a municipal utility. They work on 5-year cycles. Based on data analytics, we helped them understand that the circuit going through this mountain valley that was inspected once a year by ATV, only during the summer, never during the winter, it was ultimately being impacted by vegetation. They had no clue it was creating blinks. Blinks in the world of utility, it's a momentary outage, no problem, no big deal. The problem is that vegetation eats through that line, right? You've got serious risk of wildfire. And so through data analytics on capturing blinks at the very edge of the end of and along their circuit line, they immediately reallocated dollars to upgrade that circuit to mitigate not only outages and inconvenience to their customers, but wildfire risk. That's the power of accessing data, of digitizing a grid, and ultimately leveraging data analytics. So with that in mind, 3 key takeaways as we start to transition to the panel. From our view dealing with our utilities, data analytics and artificial intelligence, it has to be relevant, solve a problem that the utility has to deal with today. It has to be intuitive. A lot of utilities don't have data scientists on staff. So it needs to make sense. And it's got to be compatible with the existing systems that utilities rely on today. Otherwise, you get immediate resistance inside the culture of a utility. And so, one more point. I'll leave you with this as we transition to the panel. From our perspective, as we think about the utility of the future, it's no longer acceptable for the utility to just be a power company. The utility of the future has to be a data company. In order to become a data company, they have to digitally transform the distribution grid. In helping utilities do that, we create a historical milestone for each of those utilities, much like Thomas Edison did in 1880. And from those historic milestones and capturing all of this data, we can help utilities not only continue to count the kilowatts, which they have been so effective in doing since 1907, but most importantly, they can also count every corresponding kilobyte of data that goes with the delivery of what they do every day. If we can count every kilobyte, then we can absolutely leverage the expertise and the technical advancements in computer science, in data analytics, and artificial intelligence to solve problems like the brief case study that I provided for the town of Estes Park. So with that, thanks for the extra minute, Elizabeth. Andreas, thanks for hosting us. Thanks for listening.